My name's Chris, and I'm going to talk to you today about the future AI stack, why we're betting on an all-Elixir future from ETL to deep learning. So who am I? This is my first Elixir conference, which I've been dying to go for a very long time. I am a husband and a father of one human, a wonderful little boy, and 2 cats who are also wonderful little boys. I'm an economist. I turned data scientist. That's kind of what I'm passionate about in my professional life when I'm not playing with my kiddo or the 2 cats. And I'm co-founder and CTO at a company called Amplified. I'll talk a little bit more about that in a bit. If you have been kind of working in the data science community in Elixir, you may know that I am the author of a library called Explorer, which is a data frame library for Elixir, and Tokenizers, which is a little bit smaller. It's basically just a way to bind to Hugging Face tokenizers. Tokenizers are just a way of getting textual data into a numerical format that you can plug into machine learning libraries or machine learning models. And I'm a PhD dropout, which some people wear as a badge of honor. I don't. I actually really loved being in academia. I loved working on my PhD, but I felt like the company that I started with Amplified could do more than what I was doing during my PhD, and I'll get into that in a little bit. First, cat tax though. Those are the 2 little boys, and they're wonderful. They're brothers. So it's not often that you get to do a PhD or not quite complete a PhD in a field that's not to do with computer science and then get up and talk about it at a developers conference. And so, I mean, I guess it's not really that common that many PhDs get up and talk about their PhDs at all. It's a struggle even getting your advisor to read it sometimes. But this is a slide from my PhD upgrade seminar, just kind of saying the title of my PhD, which was the relationship between innovation and climate policy, a new approach with machine learning. What I was trying to figure out, and I promise this will make sense in a bit, what I was trying to figure out was why and how does climate policy affect innovation? How does it affect the rate, so the amount of innovation, the speed of innovation, and the direction? Which way is that innovation going? Are we, are we innovating a whole bunch in new gas and oil technologies? Are we innovating in technologies that can support renewables? You need to know these things if you're going to understand the impact of a climate policy, right? And how do you actually measure it? So you use patents, right? That tends to be the best way to go at it. We have something discrete in a patent. We have something that you can count. We have something that you can classify. And I understand that if you may be confused being at Elixir conference and being lectured about patents, we're getting there. So patents, they have a lot of information in them. You can kind of see, here's a US patent application, and I have put a little red square around a classification code. There are about 230,000 of those classification codes, and they pertain to the technology area that a patent is in. A patent can have more than one classification code associated with it, and we can use those to try to get an understanding of the direction and rate of innovation. You can kind of intuit this, right? So if we're seeing more patenting happening in a particular classification area, then that means, okay, something is happening to propel us in this direction. And usually the way that we measure that, we aggregate it, we find out ways of kind of measuring this at, like, let's say the firm level or the industry level or the national level, is we make very big vectors. Who here knows what a vector is? It's going to matter later. Okay, so that's good. Basically just a long list of numbers. Each element corresponds to in this case, a patent classification code, and have 0 for all of them and 1 for the classification codes that apply to that given patent. You can then add them together, right? And you understand that the patent, that the vector has a magnitude, so the size of that vector, and a direction. And just below that little bit of vector there, you can see what we call the Jaffe distance, which is a way of measuring kind of the similarity between two firms, is if you add up these vectors and you look at the angular distance, so which direction they're pointing, you can kind of get an idea of how similar two firms are. So I'm looking at this, and you can kind of see if you've got 230,000 zeros and 229,000 zeros and 998 and 2 ones, that's quite challenging, right? It's very sparse, and you aren't getting a lot of detail, right? Just 2 elements of a vector doesn't tell you a lot about what that patent's about, okay? So when I was working on my PhD, what I was trying to figure out is, we've got all this additional data. We've got so much additional data in the patent information, and how can you capture that and bring it to bear into something that looks a little bit more like this? A smaller vector, right? But a dense vector, a vector that doesn't have a whole bunch of zeros, a vector that has a whole bunch of mostly very small numbers, right? But what you're getting at there is nuance, and a nuance that we didn't have before, and it's nuance that also captures information that's not just in the text. You can't just rely on keyword counts with patents. You can't just rely on, on something like, who here has heard of TF-IDF? Yeah, a couple of people. It's basically just a way of saying, all right, these words kind of show up a little bit more frequently in this document compared to the rest of the documents. But again, it's based on counts. It doesn't really give you that much information, okay? So I wanted to figure out a way of capturing the technological information that's held in these patents and get a really good representation of that technological information and put them into places in technology space. Now, around this time, so around 2015, I'm working on this PhD and trying to figure all this stuff out. A couple years prior, I had met a guy, friend of a friend. He's working in IP consulting sales, really passionate, really geeky about patents like me. You can tell I will not stop talking about patents if you let me. And so I have some drinks, London, by the river, chat about patents all night. It's very romantic. Nothing, I don't really think too much of it. I met kind of a like mind, and that's great. A couple years later, I get a phone call out of the blue. This is about 2016. And it's Sam, the guy that I had talked to about patents. And he's saying to me, listen, I work in this industry. I work in patents, and I am seeing just so many things that are frustrating. Companies are losing money left, right, and center on R&D. Right? You can be working on something, your IP guys haven't found that there was a patent that you were actually infringing on or would be infringing on with the thing that you have been investing your R&D into, and you end up getting to a point where you just got to drop this thing that you spent millions of dollars on. Bad patents are being granted left, right, and center, and then found later after millions of dollars of litigation, and it's just a slow, challenging, difficult process to find prior art. Prior art is the term that we use in the industry to talk about patents that already exist when you go to invent something or come up with some new invention. And the way that people typically did this was that they would do effectively Boolean search strings, right? So they'd say, all right, I know this technology area. I'm going to come up with these very long search strings. I mean, we're talking like hundreds of words where you're saying like, all right, I want to find this word within 3 words of this word, but not this word, all this kind of stuff. And you end up with a list of like 1,000 patents, 2,000 patents that actually meet these criteria, and you then have to read them all. And you don't know which ones might be the most relevant. You don't know if you've missed things, which you probably have. And you've got to read 2,000 patents, right? Like, it's kind of crazy. So we started this company, Amplified, and the whole purpose is to try to make building and launching breakthrough technology faster and cheaper. There's all this information, like I said, it's out in the world. We've got everything that humans have basically ever done. We've got available in patents and scientific documents, right? Finding and using that information, it's hard, it's difficult. But if you've got the right information, you can get to your invention faster. You can get to your innovation faster. And so this, to me, as someone who's really driven and passionate about the kind of impact that I could have, this was something that I just wanted to jump on, right? So we started this company. And now let me take you on a little journey that's got a little bit more to do with Elixir, with this company. So I'm, at this point, I was a PhD student, right? So I had been working on data science. I'd been using Python. I'd been using R. And I had been building these models, statistical models, machine learning models. But I'd never built a web app. I had never built a product of any kind, right? And I'd just been going and doing research. I've been doing some data engineering. Patent data is big. I'd been using Spark and I wasn't just kind of locally doing some data frame stuff. I was doing a little bit of large scale work, but I had no idea what I was doing, right? So let me show you where we ended up very briefly. So this is the okay. Let me see if I can move this over there or mirror. I actually don't know now. Let me turn the mirroring back on. Mirror. Here we go. So let me show you. This is kind of where we ended up, right? So on the left, you can see that we've got this area where you can put your invention description in, and on the right, we return all the patents that we think are relevant out of every patent in the world, but sorted by relevancy based on the machine learning models that I built. So this was our vision from the very beginning. This is what we wanted to show and what we wanted to build and what we wanted to give our customers. We've got the ability there you can add a keyword and start to move like drill down. You can actually see it highlight in real time. We wanted to be able to create this iterative process for finding prior art so that you save those millions of dollars from your R&D team, so that you save those $1 million on litigation. We wanted you to be able to go through and kind of work on it like a project in a collaborative way. So we've got ways of discussing. We've got kind of chat here. We've got that you can mark these things as relevant, not relevant. And that actually changes the way that we order the results. So you can resort after you've kind of marked things up, and it will figure out a way of showing you the things that are now the most relevant, okay? So you kind of can see that this was the end goal. I had no idea how to build it. Let me go ahead and turn off the mirroring again. And I want to just take you on a little journey with me, all right? So how do I get there? How do we build this thing? How do we get to this point? So everyone just says, all right, you're already comfortable with Python. You know what you're doing. Just do it in Python, right? Just go and do it. Man, I didn't know what I was doing. I didn't know what I was talking about. I went and I picked up Django, and everyone says, oh yeah, Django, it's lots of, it's great. It'll make it easy for you. But I didn't know what the magic was doing because I didn't even know what I was trying to get done in the first place. So there's a whole bunch of magic. There are ORM abstractions. I'm really comfortable with SQL, and I'm sitting there fighting this thing, going, I don't know what's going on. So through a couple of different iterations and just feeling really frustrated, I don't know how, but I stumbled across Elixir. And being someone who cut their teeth on R had a pipe operator a couple of years prior. I was like, oh yeah, okay, this makes sense. It's functional. Ecto isn't an ORM. I can do what I need to do, and there's just not all this magic. I can see it happening right there in front of me. So you guys all agree with this, right? You're already sold on this. I don't need to sell you on using Phoenix for this kind of an application. It's wonderful. But this is about 2018, I think, when I finally got to this point, and so live view just wasn't a thing yet. Right? There was a situation where I didn't know what I was doing. As I said, nobody ever got fired for buying IBM. So I just said, all right, what's everybody else doing? You're doing Elixir backends and SPA front end, right? Okay, so I'm going to do that. I'm going to go for the mullet model. We've got business in the front with React. That's what everybody's signed on to. And we got the party in the back, which is Elixir, which is fun, right? I had a lot of fun writing Elixir. It was great. We were doing GraphQL. It was wonderful. But I was really bad at React. still am. I'm not very good at JavaScript, and I just don't like it. So it was me kind of just dragging my feet along, and we kind of grown a bit and hired a few people who were able to kind of take that weight off of my shoulders. But we were, kind of building on a pretty, what's the word? A pretty weak, I think, baseline. And so we were ready to rebuild. And when we were going through this process of rebuilding, it's just woodshedding, left, right, and center, right? Like we were figuring out what GraphQL library are we going to use? Are we going to use TypeScript, or are we just going to use regular JavaScript? Are we going to use this GraphQL library or that GraphQL library? And so we're coming up with all these different, like, how are we going to sort out authentication? How are we going to sort out authorization? We got to duplicate the effort on the front end and the back end. Again, I'm preaching to the choir. I know this, right? But it was just such a struggle. So one weekend, this is about finally at this point, we're a couple years on, and it's 2020, and I am just like, live view sounds really cool. Live view sounds really cool, but is it just something shiny? Is it too early? Our app is really interactive. Is it going to work? Can we actually achieve what we need to do? So I just sat down in my room. I did the kind of like CTO thing that I needed to do. Is I needed to prove to myself, what am I missing? Am I missing something? I sat down in a dark room for a weekend, and I bashed out probably 3 months worth of work at the rate that we were going, and I built the first version of our patent display page, and it was joyful and it was fun, and you know what? It's still, to this day, 2 years later, that page hasn't actually even changed that much. It was fantastic. And so I'm sold. It's magic, right? So 2022, I'm saying to you, I want to do all Elixir forever and ever. That's what I want to do. It's the best. I'm having so much fun. My team is having fun. We're moving faster. We're shipping features that would have taken us ages otherwise, just ages. Things like I showed you the chat before. We're using presence. We're able to do things like have editors in our projects that are able to hand off to other editors using presence. And it's easy. We're using PubSub. That's what you saw before with that keyword highlighting happening in real time. That's happening with PubSub across the app. And this is happening distributed, right? Like we've got a cluster that's running all of these different things, and you've got live views that are connecting from different places, and it's wonderful. We're having so much fun. So we want to be able to use Elixir forever and ever, but there is a problem, and that's ETL. Extract, transform, load. Who here is a data engineer? Yeah, a couple? All right, yeah. Who here ends up doing data engineering anyway, even though they're not a data engineer? Yes. That's kind of what happens, I know. So we've got this whole ETL pipeline. It's in Python, right? It's in Python. Let's talk about that a little bit. I want to talk about data engineering gone wrong. I want to tell you a little bit about our ETL and about what's going on there. So we've got 120 million patent documents, and they're not small, right? Some of them are hundreds of pages long. Like we're talking, it's probably like 5 terabytes of patent data that we're dealing with, okay? 2 to 4% of them are updated every single week, and that's talking about like those are corrections, those are new patents, those are deletions. So it's a lot. We're talking, on the order of a few million every week changing. We've got multiple deep learning models that we're using to take those patents and embed them into a dense vector, like I showed you before. And, oh man, the data's in XML. Who here uses XML day to day? Yeah, of those people, who wants to continue working with XML day to day? I see literally no one. No one raised their hand. Okay, yes, so much XML. Basically, just as a word of warning, if you ever see a document like this that's about 20 pages long and looks like this at the top, just run away. Because you see these kind of specifications and all this good stuff, and you just know that you're in trouble. Because nobody ever keeps up with the specification. It's never what you expect it to be, and not to mention, man, that's just so complex. It's so convoluted, right? So we have our data, those 120 million patent documents, we actually go and buy a standardized or normalized version of them from a provider. And what they do is provide all of that data as a Postgres database, okay? And it's in a star-like schema. So at the center, the image on the right is actually not a perfect representation of the schema. At the center is the fact table about the patents themselves, and then kind of branching off from that are all these different sections of the patent. So it might be like the classification codes, it might be citations, it might be abstracts, titles. Each of those are a different table in Postgres. And each of them is XML content, okay? So there's nothing that's already been parsed. It's all just kind of these chunks from the patent offices. And we've got weekly updates that are staggered across the week based on where the data is coming from. So, you know, Monday, Tuesday, Wednesday, we've got different data coming in. And it uses a load ID system, right? So you've got like a modified load ID, a deleted load ID, a created load ID. And basically what that means is that the data provider will tell you that there's that we're working on this particular load ID, and you can go and check when it's done, and then once it's done, you can do something with it. So it looks a little bit like this. We've got the patent offices that are providing to the data supplier, who are sending it to our data warehouse that we manage, and then something needs to happen to it, right? We need to do something with it to get it into our search database, okay? So some of the requirements for the question mark part. We've got to prep the data for ingestion, so it can't just be XML anymore, right? That's a very ambiguous way of putting it. We need to get it into a single kind of document, right? We've got to take it from all these different places. It's got to be in a single document, and that document we then need to embed it into a vector format for the AI-based search. We need to index it and design it such that we can use keyword-based searching as well, and in conjunction with our AI-based searching. And we need to be able to index the metadata so that we can do filtering. So kind of what I showed you before, somebody might say, I'm only interested in things that were from this date to this date, or only things that are from this assignee, only things that are from this patent office, that kind of a thing, but I still want it sorted based on relevance. So let's talk about my first attempt. I'll just run you through a few of the thoughts that were going through my head when I started designing it. So obviously, this needs to be in Python because our machine learning models use Python. Okay, me. We need this to work quickly at scale. We'll definitely need to join some of these giant tables. I know what to do. Let's use PySpark. Also me. We'll certainly need to explore this data and do complex analysis on the whole thing. So we should definitely store intermediate tables in S3 for querying with Athena. And I feel like everybody here should probably know what S3 is, but Athena is kind of an offline, large data way. It's basically AWS's service for Apache Presto, which is a way of going and querying data that's actually on disk, doing kind of online analytical processing type stuff. Right, okay, so we've got these kind of thoughts about requirements. Not exactly the best organized list of requirements that anyone's ever had, but you kind of see where we are. So what do we end up with? I'm going to show you this. I'm not going to show you the code. I'm going to show you the counts on the code. This is from Slock. So what you're seeing is that for each language that we've got in there, we've got 26,000 lines of Python to do this thing that we need to do. We've got 10,000 lines of JSON. I think that may be what is counting YAML. I'm not sure. It's not nice, I'll tell you that. There's a lot. Not having a lot of fun, not a great time, okay? So let's talk about what it actually does. So every week at a certain time, Thursday morning, we begin a data extraction and transformation task, okay? And then every week at a different time, Sunday morning, we begin a data insert and indexing task. So let's talk about the data extraction and transformation task. We determine those completed load IDs that I talked about before from the data warehouse. We extract the raw data, and we save it to S3. Then we parse the XML, and we save it to S3. Then we do various improvements to the data, do some value add stuff, and we save it to S3. Then we tokenize all those documents and get them ready for machine learning, and we save that to S3. And then we embed all the documents, and we save it to S3. Now, how do we do this? What's going on? We're using a tool called Prefect, which is one of many kind of tools in the Python ecosystem. It's a data engineering kind of pipeline setup. You can do things like directed acyclic graphs, we call DAGs. And effectively what it does is you see the little text under the big create powerful data pipelines. Let Prefect take care of scheduling, infrastructure, error handling, retries, logs, triggers, data serialization, parameterization, dynamic mapping, caching, concurrency, and more. Now, if I was in a room with people who weren't Elixir developers, they say, oh yeah, that sounds like a good idea. But if you're an Elixir developer, those things might sound a little bit familiar. They might sound like things that you may have built into the language. I don't want to say anything bad about Prefect. They're doing something really amazing, and it's just part of a slew of heavyweight tools, just like Airflow and Luigi and all these other ones, that are they're making up for deficiencies in the runtime. And they're trying to do something a little bit more than I think what was designed in the first place. So, you know, yeah. This is actually this is what the first task looks like. If you go into Prefect and you look at our plan, our DAG, it looks like this. Now, if you look at that and you go, oh, that's a lot going on. There's a lot going on, because each of those dots is not something kind of trivial. It's not like, oh, just, you know, like, I'll read, you know, this job description, or I'm gonna read this particular document here. Those are mostly Spark jobs. And I mean, we're talking about like hundreds of nodes, hundreds of machines in a cluster. Towards the end, we've got embedding jobs that are hundreds of GPU-enabled VMs that are going through and chugging through data and embedding it. And we're just hemorrhaging time and money. Things are falling apart, right? And it's complex. So let me just take you to the next part, because that's not it, right? That's just the extraction and manipulation task. That's the transform part. And you've got to actually take that data, insert it into your search database, and index it. So we load the saved load the saved documents from S3, and we join it with the saved embeddings that we've saved from S3, and then we upsert them for all kinds of searching, right? And that task, for those three things that I want to do, looks like that. Again, three things that I want to do, and I've got this kind of description of all these different jobs that I've got to do. Right, I seem to have made a mistake. And I want to return to some of those quotes at the beginning. We did not actually need to join those large tables. Turns out, wasn't necessary. We could just go and get each document and manipulate each document. We didn't have to do any kind of large-scale joins. I was wrong. We did not actually need to store intermediate values in S3. That one's painful. So we're spending a few grand a month on S3, and that's even getting rid of the old data. And we're spending hours per week, hundreds of dollars per week on an inefficient ETL solution, okay? And we've also got customers waiting on our data, because, you know, we're running this every week on a Thursday. They're getting, you know, the data from the previous week. We haven't even processed it. We end up with like a week and a half of lead time when we're having data updated every day. And for some use cases, you need to keep an eye on what's going on, particularly in your competitive landscape, as soon as possible. You need to know as soon as your competitor has filed an application. You need to know what's going on. You know, we didn't start out with this kind of complexity, and you know, we didn't start out thinking that it was going to look like this. We started out with something that was relatively simple that kind of fulfilled the requirements that we had, but it grew and it grew and it grew. So kind of like the JavaScript situation that we had before, I needed to rebuild. And when it was time to rebuild, I was like, okay, let's have a think about what we can do. How do we fix it? How do we fix this problem? So if we don't need to store the intermediate data in S3, and we don't need to join the data at scale, we can stream directly from the data warehouse via some sort of ETL solution to the search database. Now, does anybody have any ideas for a library in Elixir that might be really, really good for that? Broadway. He calls it Broadway, okay? this isn't a talk about Broadway. I don't want to spend a lot of time getting into it. It allows you to build concurrent, multi-stage data ingestion, data processing pipelines, right? There's back pressure, there's automatic acknowledgement at the end of the pipeline, there's batching, there's graceful shutdown, there's built-in testing, there's custom failure handling, there's ordering, partitioning, rate limiting, like metrics, all this stuff that we needed to go and get an external solution for and pay for like a SaaS solution for Python. It's just there, and it's just ready to be used. So we end up with a situation where we've got the data warehouse, we've got a little task that runs every day and goes and checks and sees if we've got load IDs that have completed. And if we do, we take the publication IDs and we stick them into SQS, Simple Queue Service on AWS, right? Broadway, we then have an auto-scaling cluster in ECS with Broadway. And Broadway is taking publications off of that SQS queue, batching them, which is awesome because it reduces the load that we have on the database connections, and processing all of that data and putting it into the search database. That's pretty awesome. Now, Elixir isn't, it's not perfect for everything. It's not perfect for every part of this job, particularly when you're dealing with XML, right? So there are a number of issues with the XML ecosystem with Erlang and with Elixir. It's not bad, but it's not great, okay? But when you're working with something like XML, when you have a language that isn't statically typed, you are always going to be imperatively querying that data. You're going to be using XPath selectors. You're going to be using, you're going to be saying, all right, I want to get, turn it into a map. I want to go get these elements in the map. So just digress for a second and just say, if you need it, Elixir can provide statically typed, mostly declarative data serialization and deserialization today. How? a bit of Rustler. It's a little bit of misdirection here, but this wonderful thing about Elixir is that you can rely on it for managing the data pipeline. You can rely on it for handling back pressure, all this good stuff. And then if there's a problem that you need to solve that would be that you could use a different language like Rust for, you can just go call it. Rustler is incredible. Big shout out to the community that has been working on Rustler. I can just go and I can define on the right here some structs that I want the XML to look like when it's been deserialized, and just basically goes out and does it. And I just call that deserialization as a single Elixir function in my ETL code. So that's pretty awesome. On the left, you can see the old code that was actually in Python, and you can see how it's kind of imperative. It's only a fraction of that code, but you're going through and you're saying, all right, I want to find this XPath selector, and I want to turn it in. I want to get the text from it. You're doing these kind of tests to see if it's none, if it's not none, then do this. If it is none, then do this. It just makes your life very, very difficult. But I digress. There's one problem with this ETL issue that I've been telling you about. What about the machine learning, right? We've got these machine learning models, and we need to be able to embed those documents into these vectors, right? Now, I'm not sure if anyone here has heard of this, but there's something going on in the Elixir community called NX. And specifically, within the kind of NX ecosystem, there is a library called Axon Onyx. So Axon, if you were here for Sean's talk, which was brilliant, he kind of explains the kind of theory and philosophy to bringing a machine learning library to Elixir. But he's also written an additional library that goes along next to it, that's called Axon Onyx. Onyx is kind of it's an open format that's built to represent machine learning models. And Axon Onyx allows you to pull in models that you've built in another language, in Python, for example, and bring them into Elixir as Axon models. And so you can use those for inference, and it is simple. It is incredibly simple. So you just put Axon Onyx import, you get your model that you've converted into an Onyx format, okay? Now, what's amazing about that is Hugging Face. Who here's heard of Hugging Face? Few people, okay? It is, they have one of the largest model zoos, right? So they have the Hugging Face hub, which has all of these pre-trained machine learning models, and they have a way of converting basically all of those into Onyx, right? So you can just go grab any of these pre-trained models, and you can bring them into Elixir. Now, we happen to have our own model, and we were able to convert that into Onyx and bring it into Elixir. But it opens up incredible possibilities for inference, okay? So we've got, at this point, we've called import. We've told it what the batch size is that we want and the sequence length that we want for these textual models. And we end up with an Axon model and the parameters, and we can go and we can infer in our ETL pipeline. That's pretty awesome. So what does that give us? Before, a full rebuild, which is something that we have to do every now and again if we change the schema that we want the format to be in, take about 3 to 4 days. And that's with a bunch of machines. I mean, we're talking at points thousands of nodes running, 3 to 4 days. Now, 6 to 8 hours. That's huge for us. Before, a full rebuild would cost $2,500, around there, anywhere between kind of $2,000 and $3,000. Now, about $650. Before, our weekly ETL would be on the order of 8 to 12 hours, okay? Now, minutes. And instead of happening once a week, it's happening every day. So, is Elixir ready for machine learning model inference? Yes, I think so. We've got an additional benefit, okay? So this is very simply what our architecture kind of looked like before. So we have our search database, we've got the web app at the center, we're driving towards a monolith with that web app. Application database, S3, Redis as an L2 cache, and we've got these two model services that are Python. They're full microservices that have CI/CD, our infrastructure, and Terraform, our deployment pipeline, all that good stuff. And now, because we can do this on the fly inference in our web app, they're gone. But we've got another benefit, which is that because we have built our ETL in an umbrella app and we've moved towards a monorepo, we're able to do code sharing. And one of the most amazing things to me about doing that code sharing is that I'm now able to access our data warehouse directly from our application. So I'm just going to very briefly show you something, which requires me to turn back on the mirroring, which is that if you look at one of our patent pages here, we've got a whole bunch of metadata, right? We've got PDF downloads, the title, drawings, all that kind of stuff. And we've got this little thing right here, which is not available in our production system. It's in our staging system for admins only. But what I can do here is I can look at this raw format of the patent, and what it's allowed us to do is prototype way before, at the beginning of the line. So we can actually go and we can use the same code that the ETL pipeline is using to get certain aspects of the patent data, and we can start to use it to develop slightly less effective versions or less efficient versions of the data, presenting the data, and then push that through our ETL pipeline so that it then ends up in our search database. We can go through and decide which bits of data we want to put through into our search database. That makes a huge difference for us. So let's play here. Let's go back to away from mirroring. And so you might be wondering, what if I did need to do those large joins and do the analytics, right? Because not everyone can go and change their ETL from something that has certain requirements and can say, I actually made a mistake, I didn't know what I was doing, and I need to move to something streaming. And that's actually what motivated the initial development of Explorer. So right now, when you're working with Explorer, you're working with data frames, right? So data frames are two-dimensional data structures. You've got series, which are the one-dimensional data structure, and you kind of can go through and chop and change and do all sorts of fun stuff, right? So you can do filtering. In this case, we're showing what would happen with that data frame if you filtered where the country is Afghanistan. You get this list or this data frame, right? But the way that it was designed was it actually took inspiration from NX. So NX allows you to use different compilers and backends, and Explorer allows you to use different backends. So right now, the backend is actually Rust. It's a library called Polars. But anything that can meet this contract, this behavior, can be implemented as a backend for the same front-end API in Explorer. Something that we've started work on is there is a library in Rust called Ballista that allows you to work on these big data frames in a distributed way. So this is a case where when we have that different backend, when we have that Ballista backend that fulfills this contract, you'll be able to go and do Spark-like manipulation just in Elixir. So whatever kind of ETL you have, Elixir can probably do it today, even if it's got machine learning, even if you require huge amounts of data to move through, either now or in the near future. But wait, there's more. So we're working on the machine learning inference. That enabled us to move our ETL entirely to Elixir. Okay? And we've got huge cost savings because of it, time savings. We've got developer happiness. We're no longer siloed. We don't have Python developers who are basically just struggling to talk with Elixir guys. But what about the actual research? What about making the model in the first place? Do you have to go to Python and maybe rewrite some data loading, change the language that you're working in, go through that process of changing things to Onyx, going through the whole process of maintaining things in Python? Do you need to do it? Well, at Amplified, our requirements are really high, right? Our models are in production. This isn't theoretical for us. It's not a trivial thing to switch. We know that anytime that we make a switch, it has to be better. We've got people we've got customers in global Fortune 100 or global Fortune 500 companies. We've got very large R&D departments. We've got patent analysts. We've got patent offices. We've got patent attorneys. They're all using this at very high stakes, right? And we're working at the bleeding edge. We're not just sitting on something that's old and kind of fuddy-duddy. Everything that we're doing, we've got everything from straightforward kind of bread and butter data science through to really large language models with novel architectures. How does Elixir keep up with something like that? Can it keep up with something like that? And more than that, we know that the models that we're producing, for what we do, they are the best in the world. And I'm happy to come out and brag about it. They are the best in the world at what we do. And that's not from our internal metrics. There are a whole bunch of neutral third-party studies that are comparing the kind of Boolean search that I explained before and AI search. Boolean's actually generally more consistent. AI has been very hit or miss. Working with long documents is a challenge, right? And recently, there have been some AI kind of breakthroughs that have beat Boolean in some cases, but they lose big in others. And Amplified's the only one that's beating both Boolean and other AIs in every single case that we're seeing, right? So I'm going to sit up here and I'm going to make this brag. We have built the best model in this industry. So I ask you the question: is Elixir ready for machine learning research? So not just serving models we trained in Python. Let's have a look. I'm going to take you to a live book that's running right now. It's been running 25,000 seconds, so I restarted it this morning because I hit a data issue. And you can see, actually, if I refresh, come on. you can see actually the plot of the loss going down. I restarted it this morning, so you don't get the dramatic dip at the very beginning, but we're steadily reducing loss over time. We've got this checkpointed bit. You can kind of see the loop. I actually owe Sean a PR on the updating Vega Lite plot in real time. So this is not something that you can do in Jupyter Notebook, for example. I've built this very simple Vega Lite chart, and that Axon loop, while it's training, every 50 steps is actually updating that plot. So if you were to sit here and watch it, you'd watch it very, very, very slowly going down. You can't do that in Jupyter. Now, I've taken a checkpoint kind of midway through, and I've gone and I've run it through my live book benchmarking. Now, what I want you to show you is this. So the top one are the mean of the ranks that we've got. So we've got 1,000 known citations, and for each of those citations, we're going through and we're checking what the rank is of the cited document within the list of 1,000 cited documents. So the true citation should be close to 0, close to 1 every single time, right? And on average, our old model on the bottom was giving you a rank of 32, 31.93. The new model that's training in Elixir gives us 12.27. Now I'm going to let that keep going. I'm going to let that keep training. And very soon, this model that we trained in Elixir, we're going to be running in production. And it is nearly 3 times better than the old model. So let's go back here. Let's stop mirroring. Let's press play. Is Elixir ready for machine learning research? You betcha. Not only are we able to do it in Elixir, which is great, what's exciting is that I'm having the same experience that I had with LiveView a couple of years ago. I'm switching from a Mullet app to LiveView. I'm moving faster. It's more joyful. I'm not spending time on low-value table stake stuff like reproducing data loading pipelines and trying to do things like get that data loading pipeline to do things like intermediate caching and batching. I'm sharing code. I'm spending my time doing high-value work. Now, how do I know that that's happening? What metrics can I tell you? I was able to put this together on the order of a couple of weeks, developing this model, when the previous model took months. And most of that work isn't actually the research side of things. That's certainly part of it. It's mostly just building all the stuff that goes around it, right? It's building the data loading pipelines. It's building, making sure that the tokenizer is doing what you expect it to do, making sure that your analytics are correct at the end of the day. Yeah, it is a LiveView-like experience for me, and that is just game-changing. So the main benefits, we've got portability, developer experience, code sharing, and there's no magic, right? So what do I mean by these? Portability is a situation. In terms of portability, it means that I can train a model, I can use an Elixir model, and I can throw it anywhere. Now, I'm going to come back to that in a second because I want to break out, because that's actually one of the kind of biggest pieces of benefit that you can get from using Elixir. The developer experience is spectacular. Livebook is just something else entirely. Even just ordered execution, which means that it executes the cells in order as opposed to just whenever you click on them and press OK. Make sure that the previous ones are stale, all that kind of stuff. That when you're working in kind of these environments where your mental load is meant to be focused on the machine learning question, you don't have to try to carry all of these different things like, oh, did I execute that one before? Did I execute this one before? What order did I execute it in? All that kind of stuff. Even just that changes the developer experience entirely. There's code sharing. So I keep going on about the data pipelines, right? I'm able to use, again, the code that I've written for the ETL. I'm able to use the kind of libraries and code that I've written for that in my machine learning situation, in my machine learning data loading. I'm able to go through and say, all right, let's get this data from the data warehouse, let's get this data from the search database, and process it through. And I'm actually working with the same data and the same functions, and that means that I'm not introducing those areas of uncertainty. When I recreate the query in Python, I don't know if I've got the same query as what I've got in Elixir. When I'm using the same structs, I know that I've got exactly the same data and the same checks and the same manipulations. And so I know that what I'm training on is the same thing as what my customers are going to see in production. And there's no magic. So I keep harping on about the data loading and the data processing. When I'm working with Python machine learning libraries, for the most part, I can't rip it open and have a look at what's going on. There's almost immediately, you end up going and calling a C++ library. You end up with quite convoluted different kind of things that you're managing. And so, but with Elixir and with Axon, Sean talked about this quite a bit. Everything that you look at is just Elixir. It's just Elixir, right? So you know what the machine learning library is doing, and you can go and crack open the hood, and you can actually very easily write different loss functions, different step functions, all these kind of things that you can do, and you can trust that they're running as quickly as is possible, because you don't have to go and try to play the games with the different kind of redirection and manipulation that you have in these very large scale and often convoluted machine learning libraries. So I just want to jump back to the portability issue. This is what PyTorch looks like to download. You have to go through a multi-step process to determine which version of PyTorch you're going to get on your machine, right? When you're developing locally, you need one version. When you're developing in the cloud, you need another version. When you're deploying to production, you need another version. And Python doesn't have the kind of setup like with mix and mix install, where you can kind of where you can make it where you can just treat it as just code, right? They've got a completely different dependency setup. And you often have to choose between, do I want this one from pip? Do I want this one from Anaconda? I don't know. In Elixir, I just throw this mix install script at the top of my live book, and I just say, all right, I want to use the default backend. I want to use EXLA for that default backend. And guess what? EXLA will pick the available client to allocate the compute tensors, in this order. So CUDA, ROCm, TPU, or the host, right? And that means I can throw that code on any hardware, and I will get exactly what I expect. I will get acceleration to the best level possible, okay? That's game-changing for us. It means that we can go from being, from just working on Python and fighting our DevOps, trying to figure out how do we deploy this, how do we train here, how do we deploy it to this situation, can we put it on this computer, to just install it, just mix install. It's not all perfect, so where did we struggle? So the first thing that I'll bring up is experiment tracking. Experiment tracking is really well developed in Python, and what that means is basically anytime that I do a new run of my model training, I want to be able to go and see how it did based on the metrics that I'm tracking. That is very much an open space. Sean touched on this in his talk as well. I'm definitely getting some benefits from using Livebook and using Vega Lite, but it's not perfect. Distributed training, again, I know that this is something that's in the works. When you have very large language models, you need to be able to distribute them onto multiple GPUs. You can't do it on a single GPU. So this is a place where I know that there's going to be some work in the near future, but that will make a very big difference in the types of models that you can build and whether you are fine-tuning or building a baseline model, those sorts of things. Again, something Sean touched on and invited kind of chat about, and I think it would be a good idea to have a discussion about how to do this, is model serialization and deserialization. How do you save it and load it from disk? It's kind of, it works right now, but it's kind of nascent, and there could be better ways of going at it. And mixed precision training. So again, this is a memory saving kind of thing. It is table stakes when you're working with very large language models, and it's kind of halfway implemented in Elixir, and it will make a big difference in terms of the types and the size of models that you're able to train in Elixir. But these are relatively minor. These are relatively minor tasks. So Amplified is making the switch to all Elixir for our ETL, for our machine learning, and you can too. Thanks.